Welcome back to the new video. In this video, we are going to see how to do the exploratory data analysis. So let's see in step by step how to do the EDA of data. So I have wrote the steps over here. So the steps include the step number 1 is importing libraries, then the read the data. Then we will do the sanity check of the data like checking the missing value, duplicates and garbage value. After that, we will get the statistical summary to understand the central tendency and the distribution. Then we will do univariate analysis like histogram and box plot. And we will do the bivariate analysis like by using scatter plot and correlation heat map. After we will do the outlier detection in the dataset. Then we will do probably the feature engineering, then last documentation. So this is the flowchart of the steps, so it will be easy to understand. Like first step, we will import libraries, then read data, then we will do sanity check of the data in terms of missing value, duplicates and garbage value. After that, we will get the statistical summary in step 4. In step 5, we will do the univariate analysis to understand the unique columns like the histogram and box plot to be used to do univariate analysis. After that, we will do bivariate analysis like scatter plot and correlation. Then we will do the outlier detection by using box plot. Then we will do the feature engineering to create extra feature from the data. Then we will do the documentation of the data. Before diving into the steps, what is EDA? So EDA is exploring the data both in statistically and visually to understand the structure, pattern and relationship between the data. It will help us to in the decision making or taking any steps in further analysis. So this is why the EDA is very important while doing data analysis. Then let's get start the EDA steps. The step number 1 is import necessary libraries. So first we have to import the pandas, numpy, matplotlib and seaborn libraries. So pandas and that numpy is used for the manipulation of the data. The matplotlib and seaborn for visually present the data. So first I will import all the necessary libraries. Then the step number 2 is to read the data. So we need to read our data to our data frame before making any manipulation. So we have to write pd.read. Based on the file, we have to give the name, that is CSV file. I have currently using CSV file. So the name of the file we have to copy. So I have the file like the YouTube dislike. So I'm using this file. So I copied the name and I will paste it over here. So this is my data set for this exploratory data analysis. So I will read this file. Then so I will store it in any variable. So I will store it in df. So my data frame of this YouTube file is now stored in df. So if I now print df, so this is my data. You have the information like video ID, title, channel ID, channel title, published at, video count, likes, dislike, comments, and tags and description and comments. So this is my data set. So we will do the exploratory data analysis by using this file. So let's start. After reading the file, we will start with sanity check. So sanity check is to understand about the data, whether it's a clean data or not. We will check for the missing value. So how to check the missing value? So it's very simple. df.isNull df.isNull.sum. If I give df.isNull.sum, it will give the count of the null value of each column by column. So here we can see that in all the column there is no null value except that comment column. So we have to decide whether we have to impute these null values or whether we need to delete. Based on our data, we have to decide. It's not static like we have to delete or we have to impute. So it's based on our data or analysis. So we have to decide whether to delete or impute. So in this case, the data, I have 158 null values. So I will do the treatment later. So here we can understand only about the missing value. After that, we will check for the duplicates. Same way, the duplicates also checked like df.duplicated df.duplicated.sum, it will give the sum of duplicates. Yeah, here I got 0, means there is no duplicates. If you have the duplicates, you can use drop duplicates to remove that duplicates. Okay. I can get overall information of the data frame by using df.info. So df.info will give the overall information of the data. So here we can see that it will give the information like the total we have 37,422 rows indexing from 0 to 37,421. I have total 12 columns. It will give the name of all the columns like video ID, title, like that, and it will give the non-null counts of the each column. Then I have the data types of each column. Here we can see in total I have 12 column. Out of that 4 is with the integer data type and 8 with the object data type. Object means a string value. So this is how I can get the overall information of my data frame by using df.info. After duplicate check, we will do the garbage value check. So garbage value means any special character within the column, whether there is any special unnecessary data that creating any problem. So we will check for that. So how to check the garbage value? So first we need to understand that the garbage value, if we have any garbage value, for example, within any column, that will always in the form of the data type of object. So while checking the garbage value, we will check the garbage value within the column which is in the form of object data type. So first I will select all the columns with the object data type. So df.select dtypes, df.select dtypes include is equal to object. I will include the object. So it will give the data like this. After that I will get the columns of this columns. So it will give the columns of each column with the object data type. So I will copy this. So here I will write a for loop. For I means each element in this column do a value counts. So df of I means each column value counts, value underscore counts. So I will print this. So print for each column the value counts of each column. So it will give the unique value of the value of each, and I will give one the separator like print the star after each column. So if I run this, I will get the unique of values. Like here I can see there is no any garbage value as such. So by this way we can check the whether there is any garbage value. So we can also use that unique over here to get the unique data from each column, so that if you find any garbage value that comes as a unique item from that column, then you can find that is a garbage value in that particular column. Then we will do the treatment of that by deleting or by imputing with some other item. So this is how we can check for the garbage value within the data by using value counts or by using unique. So after that, in the step number 4, we will get the statistical summary. So to understand about the central tendency of each column, to understand about the distribution of the data, how data is distributed, we will get the statistical summary. So statistical summary, to get statistical summary, I have to use df.describe. So df.describe is it, I will get the statistical summary of the numerical column. So if you want to transpose, you have to give the t. So it will give the data like this. So in this statistical summary, we will get the mean, standard deviation, minimum, 25 percentile, 50 percentile, and 75 percentile, and maximum. So it will only give the summary of the numerical column. So if you want to get the statistical summary of the object data type also, so df.describe So df dot describe within bracket parenthesis we have to use the include is equal to object. So if I use include is equal to object, it will give the summary of the object data type. So how to interpret inferences from this is the view count. We have the minimum view count like 5 point, like here it will have the plus 6 means till here like 5,69,783. Like that we will get the inferences from this. We will understand about the minimum, the range of this, the view count, like here the minimum to the maximum, this is the range of this view count. Then from the likes also we have the counts like 37,422 rows we have the minimum of that and the maximum of that, the mean, the standard deviation. By the standard deviation we can understand about the spread of the data, how the data is spread, whether it's a wide spread or the small spread. Like that we will have the data for the dislike. We can see here the mean of the data. At the dislike mean like 498 because there is a 3, 4989. Then for the maximum it have the 2.39773. Then for the comments it also have the for the comment like the mean 9924. Then it have the standard deviation of 1. So by this way we can get some inferences from the data. So this is for numerical column. Then after we will get the statistical summary for the object data type. In the object data type, the statistical summary quite different from that the number. So in this summary we will get the unique count of each column. For example, for the channel ID we have 10,961 unique values. Then for channel title we have the 10,883 unique value. Published date we have 36,772 unique value. Then tags we have 28,799 unique value. Like that we have the unique value counts of each column. So this is how we can get the statistical summary. So based on your data we can get the understand about the central tendency of the each column. Then we can understand about the standard deviation, the spread of the data. Then we can get the range of the data of each column. So this is the by this way we can get some inferences about the data. So after doing the statistical summary of the data, we will get the univariate analysis. We will start the univariate analysis to understand each column. So in terms of distribution, so visually. So in the statistical summary, we get the information in the numerical form. By using univariate analysis visually, we have to use the histogram to understand about the distribution. So I will use the for loop to get the histogram for each and every column, the numerical column. So I will write a for loop for each element in df dot. I will use the same method that I used. Select dtypes. Select dtypes include is equal to number. So you can use any method to get that column that with the numerical. So I am using this method to get the columns of numerical data type. So after that I will use the seaborn library sns.hist sns.histplot to plot a histogram. So data is my data frame. So the data is my data frame. Then the x variable is the each column. So this will give some warning. So in order to minimize that warning, I will use the warning. I will import the warning library to stop the warning. Import warnings. So warnings dot filter warnings. Warnings dot filter warnings within bracket I have to use ignore. So this don't give that warning. So after that I will use the plt dot show plt dot show to show all the chart. So let's run this code. It will take some time because it have many values. So plt dot show, it's giving me a histogram like this. So it have many variation. The skewness is more, I think. So let's do one thing. We will plot a, in place of histogram, let's plot a KD plot to understand about the distribution. I am stopping this here. Let's stop this. Yeah, we will give a KD plot in the place of hist plot. KD plot. Let's run this. Yeah, we got a KD plot. So I will adjust the size of this. So let me adjust the size of the KD plot. So in order to adjust the size, I have to use the matplotlib library, that is PLT. I imported as PLT. So the figure, then the figure size, we will give the size like 15,6. Let's see. Figure, the name fig size is equal to, okay. Okay, this is my KD plot. By the KD plot, we can understand about the distribution of each numerical column. So here we can see that in the view count, the curve is right skewed. So there is a right skewness in the data. In the likes also, there's the right skewed data. Then in the dislike, it's also right skewed data. Then the comment count, it also right skewed data. So by this way, we can get the skewness, like we can understand about how data is distributed. So this is the use of histogram. So in the place of histogram, I just use KD plot to get the kernel testing line. So by that also we can understand about the distribution. After that, we will use for univariate analysis, we will use the box plot. So I will use the same code for that. So I will use the same code, then plot it over here. So in place of KD plot, I will just change to box plot. Let's see what will we get. Yeah, we got a box plot for each. Here also we have many outlier in the data. So this is how we can get to know about the data. We have many outlier, means that we have extreme values in our data set. So this is the use of box plot and the histogram to understand about the distribution. After, in the step 6, we will do the bivariate analysis. Bivariate means the unit analysis means we will compare only, we will get the understand about the only one column. In bivariate analysis, we will compare the two column information and we will plot that by using scatter plot. So scatter plot, by using scatter plot, we can get the relationship between the data. So I will use the for loop. So first I will get the column with numeric information like here. Yeah, I will use this code to get the columns. Okay, so let me get that column. So this is my column and I will plot a, so I will use this like as my target variable. So df dot, so I will use the for loop for each element in this column, this list, then give it over here, then remove this. I will use this to compare with each. So for each column in this list, sns dot scatterplot, sns dot scatterplot, then data is my data frame. Data is my data frame. After that, the X is that column. Then the Y is, I will use this like. So that's my Y. Then let's use the plt dot show plt dot show. Let's see. Yeah, we got a scatter plot for comparing between the likes and view count. We can see that there is a positive relationship between the likes and the view count. Then in the dislike and the like, there is a positive relationship, and in the comments and the likes, there's slightly a positive relationship, you can say. So this is how we can get a scatter plot for the comparison of bivariate analysis. Let me do something over here, whether we can get that line lm plot. Let me see whether there's a working or not. By this lm plot, we will get that line, that positive and negative line. So here we can see that in the view count, it's a positive relationship, and in the dislike and in the comments, it have the positive relationship between the likes and the other columns. So this is how we can get the bivariate analysis by using the scatter plot. So let me get the correlation matrix. So correlation is it will give the probability, like the percentage in the, between 0 to 1. By that we can understand the strongness of the relationship, how the relationship is between the variables. So I will use df dot, that I will use that same code to get that. So let me get that code. So this will give the, so this will give the column with the numerical data type. So I will just use the correlation over here. So this will give the correlation matrix of the data. So here we can see that the likes and view count, we have 78% of correlation. That's a strong correlation, strong positive correlation. Then the dislike and the view count, we have 68% of correlation. So let me just make a heat map of this to understand better. So sns dot heat map, sns dot heat map the data. So I will give this code. So control C and control V. Then I want the number. So I will use anote is equal to true. True. Let me see how we will get that. Yeah, we got a heat map of the column, the dataset. So here we can see that it have the relationship of the 46%. Then the dislike and the view count has 68, and the like and view count has a 78% of relationship, and the dislike and the comment have some weak relationship like 39%. So more than 50% it have the positive strong relationship. Below 50 and negative, that's showing the negative relationship. So this is how we can understand about the relationship between the variables. So this is about the heat map and the bivariate analysis. After that, we will check for the outlier. We already did that for the in the visualization. So I will use same code to get that box plot over here also. Sorry, box plot. Yeah, I will use the same. So after that, we will get the outlier of the each variable. So it will give the outlier, like here we already saw about the outlier detection. So in all the columns, we have the outliers, means we have the extreme value. So this is how we can get the outlier check of the data. Then after that, we will do some feature engineering. So before that, in the feature engineering, I will drop that the column with the null value. So df dot drop any, df dot drop any. So it will give the dataset with non-null value. So I will make in place is equal to true. So it dropped that column from that. So if I now check for the null value dot sum, let me see whether there is any. No, the null value column, the row is now deleted. So now the data is clean. So we can do some feature engineering here also. So feature engineering means the creating extra features. So for example, in my data set, I have the columns. If I can create one more column with having this information, if I create one more column, that's called as feature engineering. Means we are creating a new feature from existing column. So here from the published date, I can get the month, year, like that. So I'm creating extra feature. That's called as feature engineering. So first I need to convert that data type. So if I now check for the df dot d type, df dot d types of each column. So here we can see that the published date, that's in the form of object, but it's a date. First I need to convert that to date and time. I will use pandas. So pd dot to date time, I will give the name of that column. So the name is published at. So I will give this and I will store this in another column, that is the name of the column. Let's say df of published date, let's say date. So I will give the name as the date and I will store it in that. So if I now check for the data type of that column, so we can see the date with the date and time data type. So after this we can do some feature engineering, like we can get the month or the year. So I will just use the, I'll store it in df dot the month. The month is equal to, I will get it from this df dot date. So control C, df dot date dot dt dot month, dt dot month name underscore the month name. So let's see what will we get. So if I now check for that df dot month, it have the month name. Like that we can also get, I can also get the name of the, I can also get the year. So let me get it over here. So df another column, I will creating another column with the year. So year is equal to from this date. So from this date, I want to get the year. So dt, that is datetime dot year. Now let me see, check for the year now. I have the year column also. If I now check for the data frame, like over here, I have extra feature just I have created. So you can see over here that month and year we just created by using date column. So this is how we can do some feature engineering of the data. So that will help us to do further analysis of the data. So after doing all this EDA process, we can document our insights, what we understand from the data. So we can write like the missing value is treated, missing value is treated, then there is a, then we can say there there is outlier in the data. There is a best relationship, so we can say there is a best relation between likes, comments and the views that we just understood by using the scatter plot. So like that we can write our analysis document, our insights, like after doing all the EDA process. So this is about this video. In this video we learned about how to do the EDA. So this is just a general EDA process that we follow generally while doing the analysis of the data. So I try to cover this in a very simple and easy way. So in this video we learned about how we can do that EDA of the data. First we imported necessary libraries to manipulate and visualize the data. Then we read the data into our data frame. After that we started sanity check in order to understand the missing value, duplicates and garbage value. Then after that we to understand the distribution and the range of the data, we did statistical summary. Then univariate analysis, we did histogram and box plot to understand the distribution of the data, to understand the outlier of the data. Then we did the bivariate analysis to compare between the two data. We did scatter plot and correlation heat map to understand the correlation. Then after that we did the outlier detection by using the box plot. Then we did some feature engineering of the data by using date column. We created further feature like month and year. Then after doing all the EDA process, we did the documentation of our insights. So this is the general EDA that we follow. So thank you for watching. Stay tuned for the next video. If you find this video useful, give one thumbs up to the video. Thank you.